our final speaker today is Illyoung Choi of CyVerse at the University of Arizona, and his talk is entitled Safeguard Your Sensitive Data in iRODS Using Data Encryption Feature Available in GoCommands.
Hello, I'm Illyoung Choi from CyVerse, University of Arizona. Some of you might have already used GoCommands. For those who do not know what is GoCommands, in short, GoCommands is a cross-platform command line tool for iRODS. It is like iCommands, but it is cross-platform one, a more portable one. And I am the author of the GoCommands. And in this presentation, I present a new data encryption feature available in GoCommands and how to use it to work with sensitive data. In some research domains, researchers work with sensitive data. For example, researchers in life sciences work with human medical information. So all researchers must follow strict confidentiality laws, such as HIPAA. In terms of data, HIPAA mandates that information must be encrypted during storage and transmission. Therefore, it is important for infrastructure providers and data administrators to establish simple and effective data security policies and practices that all users can readily adhere to. The security policy includes end-to-end data encryption and consistent encryption methods for sharing data within team members and collaborators. As a big iRODS supporter, CyVerse wants to use iRODS as a storage solution for managing sensitive research data. iRODS is currently providing several built-in security measures, such as PAM authentication, authorization, and SSL-based data transfer encryption, and audit trails. However, there are two missing components that infrastructure providers and data administrators need to address. The one is encrypting data during storage, and the other is ensuring user adherence to security policies. To help working with sensitive data in iRODS, we implemented a new encryption feature in GoCommands. GoCommands can encrypt and decrypt files, not only their content, but also file names. Two encryption modes are currently supported. One is AES and the other is SSH. The AES mode uses a strong AES algorithm for data encryption, and it uses a password as a key. With this mode, it is possible to have a shared password for a group to share secret data. But using password is not very convenient and it's not very secure. So SSH mode is born. SSH mode uses a combination of RSA and AES. The mode uses SSH public-private key pairs, that is for SSH access. So it uses SSH keys for encryption and decryption. GoCommands finds SSH public-private key pairs automatically in your host. So users don't need to type a password manually. So it is more convenient. The encryption feature is seamlessly integrated with GoCommands. For example, put command encrypts data before you upload a file, and get commands decrypts the file before you download it automatically. Also, ls command displays original file names for authorized users. If you don't have proper keys, then you will not see original file names. I will demonstrate this in few slides. GoCommands uses SSH encryption mode by default. To change the mode, user can use -- encryption mode flag. For SSH mode, GoCommands will find default SSH RSA public-private key pairs under users.ssh directory. But if a user wants to change the location of the path, then he can use -- encrypt pub key and -- decrypt private key flags to locate the keys. For AES mode, users need to pass a password using -- encrypt key and -- decrypt key flags. These are command line flags. We also reserved two AVUs in iRODS for configuring encryption in GoCommands and enforcing data encryption in iRODS. These two AVUs can be added to collections only. Encryption : required attribute is used to mandate encrypted data in a collection. So GoCommands uses this value to determine whether to encrypt the data before uploading. Also, our iRODS rules use these AVUs to determine whether encryption is required for the collection. If encryption is required, unencrypted data is uploading, then the iRODS rules will reject the request. Encryption : mode attribute takes either AES or SSH as a value. GoCommands reads it and then make it as a default mode when it uses encryption. So let's talk about how iRODS rules enforce data encryption. The flow chart describes how the logic works. When a file is created in a collection, the iRODS rules check AVUs, the encryption : required. If the collection has that AVU and it is true, then the file extension is then checked to see whether the file is encrypted. All files encrypted by GoCommands will have ENC extension. So when you see here, the hello.txt file name is encrypted to this long encrypted file name, and then it has .enc extension, meaning that the file is encrypted. Therefore, the rules only need to check the file extension in the name to see if the file is encrypted or not. Therefore, if the file does not have ENC extension, meaning the file is not encrypted, then we need to reject that the file creation request. So upload will fail. So that's the logic that enforces data encryption in collection. So that is very simple logic. In order to implement iRODS rules for enforcing data encryption, we had to hook several PEPs. Because the rules need to reject uploading of unencrypted files in a collection, a series of data object create or open PEPs must be hooked. These PEPs are triggered before uploading a file to iRODS. Data object put, copy, and rename within collection. So rename and copy and put also creates a data object within a collection. So they must be hooked as well. It is also possible that a user creates subdirectories in the encryption enforced collection. In this case, the sub collections should inherit the encryption enforcement settings. So the rules have to hook collection create and rename PEPs as well. And it should copy ABUs of the parent collection. The encryption : required ABU to inherit the configuration. That is the simple way to make the collection to inherit the configuration. The current implementation of encryption enforcement rules in CyVerse does not yet handle struct file extraction and bulk registration due to data serialization bug present in the version of iRODS running in CyVerse data store. The bug is addressed in version 4.3. And then we will address this issue once our iRODS system is upgraded to 4.3. Here's a quick demo showing how put command works with encryption. I created a new collection in iRODS and added a metadata attribute encryption : required to it. This enforces encryption for all data objects within collection. Then I created a local text file, the hello world. Then I uploaded the file to the collection using put command. Since the collection requires encrypted data object, the GoCommands automatically encrypted the file using SSH public key. So when you see the file name, the file name is encrypted. And then because it uses SSH public key, SSH private key for decryption, when I type ls to list the collection, it also displays the original name of the file here. But if I move the SSH private key to another path, GoCommands cannot find the private key, so it fails to decrypt the file name, so it doesn't display the original file name here. Here's how get command works with decryption. I downloaded the encrypted file in the collection using get command. I have to use the encrypted file name. Then once it's done, then it will automatically decrypt the file name and file content. This demo shows how the encryption enforcement rules work when we try to upload an unencrypted file to encryption enforced collection. I created a new collection, and then I uploaded a plain text file to the collection. That will succeed because the collection does not enforce encryption. Then I copy this file to UGM demo collection that requires the encryption. And then this will fail because the rules rejected the file copy request because the file is not encrypted. And then the file move operation also fails because for the same reason. We plan to use the new encryption feature in GoCommands for a CyVerse Health project. The CyVerse Health project uses iRODS for storage of human medical data. To adhere to HIPAA regulation, CyVerse Health uses SSL for data transfer encryption, and GoCommand will be used to address the data storage encryption requirement in HIPAA. The CyVerse Health project also uses SFTP access for easy data management using GUI tools like FileZilla or CyberDoc. However, encryption is not yet supported, so we will address this issue in the future. To conclude, CyVerse wants to use iRODS as a secure data storage. for sensitive data. However, infrastructure providers must provide measures for ensuring encrypted data storage and enforcing encryption policies that are not currently provided in iRODS. To address this issue, we implemented data encryption feature in GoCommands. GoCommands can encrypt both file names and content using strong encryption algorithms. Also, we implemented iRODS rules for data encryption enforcement. The rules reject creation of unencrypted files within collections where data encryption is enforced. And then the configuration for enforcing data encryption is very simple, just adding an ABU to the collection. So users do not need to do any additional step for using it, but that's it. So all the work I presented in this talk is open source, so you can find the source code at following CyVerse GitHub links. And that's it. Do you have any questions?
All right. All right, do we have any questions for Illyoung? All right, do we have a mic?
Okay, I have a few online questions. One, does this feature in the GoCommands require any configuration in the server?
Actually, if you do not want to use the rules for encryption enforcement, there's nothing to configure. It is purely a client-side solution. And then if you want to use the encryption enforcement in setting for the collection, then you need to set up the iRODS rules we developed. It is just a single file, but you need to connect it with your existing rules.
Okay. The second question is, and I think Carol answered this, but I'll go ahead and ask it. It looks like the encryption decryption for the file name and content is valid only for the iRODS namespace, or does it encrypt the physical file too?
I think I cannot understand the exact meaning of your question. Do you mean
asking it encrypts the file name, but also encrypts the file content, correct?
Yeah, it both does. Encrypts the file name and content as well. Okay, and then, yeah, the use of it is even admin of iRODS cannot access the file. Should not understand who is this data for? What's the patient name of this medical data? If it's a file name. And then even admin cannot read the content of it. So that was my intention.
Okay, and I have a few more. Does this encryption decryption mechanism mean that other standard access methods like iRODS, iCommands, jargon, Python clients will work only with it says encrypted data. I think he meant unencrypted data.
Actually, they can read and write it. If I use iCommands, for example, I can download it and then I can upload it, but it is still encrypted or it is still plain. And then if I set up the encryption enforcement rules in iRODS collection, then once the collection is encryption enforced, then even I use iCommands, I cannot upload the unencrypted file to the collection because it is handled by iRODS rules, right? So iRODS rules will reject the creation of unencrypted file in the collection.
Let's go to a couple. Let's go to some in the room now. We'll get it.
Well, this setup makes it really dependent on the GoCommands, because you can only enter and extract information via the GoCommands and not in any other way. But why not for encryption rely on encryption at rest in the storage system? Because then the storage system will handle the encryption and decryption, and you're not relying on some specifics like GoCommands instead of the full functionality of iRODS. because you're now limiting very much the usage of iRODS.
Oh, yes. We can also rely on the storage level encryption, but that requires additional configuration in the server side. I mean, that was the issue we hit, and then it costed, I mean pretty high. So our goal was adding very simple encryption mechanisms that is more user friendly, and then even some others cannot see the data. I mean, for example, if we adopt storage level encryption, iRODS admin can still read it, right? Because I mean, the data encryption will be the encrypted data in iRODS will be decrypted when I access the data using as a iRODS admin. So that is possibility. So we want to prevent that one, so that the end-to-end encryption is highly required in HIPAA. So that was the our goal was providing end-to-end encryption, not relying on the server-side solution. Does this answer your question?
Yes. I understand that right now the encryption is based on information, the key of a user, a specific personal key. Do you have any plans to add collaboration features so that a group of people could access an encrypted file by after download, or also support master keys for organizations?
Oh yeah, I think the supportable master key may be an interesting feature. I think we can use some, I mean, for just the sharing the keys between inside the group. I think we can create public-private keys for the group, not for a personal one, so that the encryption and decryption can be done using that shared public-private key pairs. So that's one way. And then, yeah, I think we can currently use it if we specify the location of the group private public key pairs. But yeah, I will figure out if there is a more convenient way of doing it.
Any other questions? We got one over here.
Hi there. So I'm in awe of the elegance of that solution. It's really nice. I'm also in a bit in terror of it, which kind of relates to what Tom was saying. What worries me here from an end user perspective is the issues with users losing or leaking their keys, because once the keys in the wild, or then these can be decrypted. This is both a plus and a minus, I feel, of the solution. Like you say about having a shared key that people could use between things. Have you put any thought onto how you might encourage people to do the right thing with their SSH keys, or any assumptions about how they are managing their SSH keys?
The management of SSH keys are kind of, I mean, that's the user's responsibility actually. So yeah, actually, if you leak your SSH keys, then it is the same thing as you lose access. You will, I mean, leaking access to your servers. I mean, if you are the admin of the server. So yeah.
I think you and I understand that. I'm not so sure end users do, is my worry.
Can you say that again?
I think you and I understand that, but I'm not sure users do.
Mm-hmm. Yeah. Yeah. I'm not sure. I mean, how people think the private key is the most important thing for their system. I mean, it is most important asset. So yeah, maybe user, I mean, don't think that's an important one, but yeah, anyway, the private key is the most important thing. And the encryption is done using public key, so that the encrypted, unless private key is leaked, the data cannot be decrypted. And then, yeah, I cannot answer how users, generally think the private keys, how important it is. So.
Well, just not trying to put you on the spot there. With a follow-on question, how does the command get the private key or the public key? If the key has a passphrase or something similar? I think you might have just answered it by saying that it's only using the public key. Is that right?
For encryption, it uses public key. So the data is encrypted with public key and then decrypted with the private key. So if you don't have private key, then you cannot decrypt it. But if you share your public key with some others, then they can encrypt the data using public key. And then share it with you. Then you can decrypt it. So that's public-private key encryption. General algorithm. So, yeah.
Right. Can the command access keys with a passphrase?
Yeah, actually it can, but current implementation does not. I remember it was a long time ago, so I maybe misremembering the thing. But if it needs passphrase, then I need to give a special flag to give the password. Yeah, I remember I was implementing the interactive inputting the passphrase if it is required. Yeah, I will need to double check, but yeah, I will need to add it.
Thank you. And last question, can it use SSH agent as well to get the keys?
SSH?
SSH agent.
Oh, no. That is purely irrelevant to GoCommands, actually. Do you mean the creation of the key pairs, or?
No, I mean, so on Linux and other things, you can have the SSH agent running, so it stores your keys. You decrypt the keys once, it puts them in the agent, and then anytime SSH makes a call to it, it pulls it out of the agent. So you can have a list of keys that you can be using, it can check against them. And that was the way you can use 1, 2, or 3 or more keys.
GoCommands just relies on the keys SSH generated. So it can be just open SSH key generation command, or just SSH something. Once the key is generated, then GoCommands will rely on it. So currently there is no fancy way to find where the keys are stored. So it just finds the .ssh directory in user's home directory. So that was the only way available in Go language word. So yeah, that's what I did. And then it only currently supports RSA-based keys. So that's current limitation. So yeah, I will plan to support some other type of keys, like I forgot the name of the encryption, but there are some a bunch of other algorithms other than RSA. So I plan to support that one. And then if SSH, key storage library is created in Go world, then I will definitely use that one for more convenient data access. More convenient key access.
All right, we're gonna stop it there. That wraps up day 1 of the user group meeting. At 5:30, we're gonna head to the Maritime Museum. Thank you, y'all.
Thank you.